One of the coolest things about MongoDB, beyond its blazing performance, is the modern and flexible JSON-inspired document model. Imagine just being able to store your data the way your application already understands it, in strings, arrays, or objects, or even objects inside objects, all backed up by a powerful and easy-to-use JavaScript-inspired query language. We're going to go well beyond dusty old tables and SQL here. Join me for this course on LinkedIn Learning, where I'll tackle the basics of MongoDB, from queries to data modeling to administration, and even interacting with MongoDB from some of the most popular programming languages. Imagine this scenario. You just got a new job. You've been hired to design and build a brand new recipe site, because there aren't enough of those already. You show up for the first day of work and enter your first meeting. Your two new bosses, because of course, start enthusiastically drawing his and her visions for the site on a whiteboard spanning the wall of a giant conference room looking over downtown. Boss 1 says, "This site needs to be fast and scale." And Boss 2 says, "We need to make sure we have user comments, and we need to be able to convert the recipes between imperial and metric. We're going global. Don't forget about likes. Oh, and user ratings for the recipes. We need a quick meal section, and we need to make sure we have really easy way to tag these recipes, and organized by dinner and breakfast. We're going to need a JSON API. Don't forget, we're going to hire 5 more devs. They need to be able to onboard quickly. Also, I want to make sure we can easily find any Polish recipes. We're going global." Your head is spinning. All these features. It's going to take forever just to come up with database structure to organize this. So many tables, so much joining, and it has to be fast. You're starting to second guess your decision to take this job, and it's only just past noon. But then the tacos arrive. Well, at least we have tacos. But what if things didn't have to be so complicated? What if we could do all these things in a simpler way and make it fast? What if instead of designing complicated architecture of tables, we could use rich documents? MongoDB helps us do this with its document model. We can store things more naturally in a format that fits nicely into modern applications. Oh, and it's fast too. With MongoDB, we can take care of almost all the features the bosses requested in one single document. For example, we could take our title and a description, and an array of user comments, and an array of ingredients where we can break it out by quantity, amount, and unit, and an array of likes with user IDs, and an array of tags, and even a type field. We're going to be learning all about how documents work, how to query MongoDB, how to design your database, code against it, and how to administer and scale it. For this course, we'll be working with a local installation of MongoDB, but we will touch on how things work in production. So before we dive into working on MongoDB proper, in the next 2 videos, I'll walk you through getting MongoDB set up on a local machine for Windows and Mac. Get ready, it's going to be a fun ride. Oh, and there will be tacos. Throughout this course, we'll be delving into many aspects of how MongoDB works and how it differs from more traditional or relational databases. From a high level, a database is essentially an organized collection of data, and more complex databases have their own formal design and data modeling standards. MongoDB falls into a broader category of databases referred to as NoSQL, where more traditional databases use SQL. Both types of databases are true databases and in fact share many concepts. Both can be run on most major operating systems, and many organizations use more than one type of database, as different database types may be better suited for different use cases. What differs between a relational database and MongoDB comes down to 2 major aspects: how the data is queried, i.e. reading and writing to and from the database, and how the data is structured. So let's start off with a brief overview of relational databases and how they work. While the concepts were developed decades earlier, relational databases first became popular in the 1980s. Ones commonly used today are Oracle, Microsoft SQL Server, MySQL, and its variants. They store their data in rows, with a varying number of columns, all within tables. These tables generally have some sort of relation. Think like a team and its players. One table could hold the data for the players, like their names, positions, etc. And another table could store the information about the team's name, their stadium, etc. To get the data into or out of these tables, relational databases use a structured query language, or SQL for short. For example, to get all the information about a player with a last name Pulisic, you could do a query like this. Select asterisk, or more commonly star, meaning all columns, from the table players where the last name equals Pulisic. Sometimes that is enough to get the data you need, but more often you'll need data from multiple tables brought together or joined. That is where relations come in. Since more than one player is on a single team, there will be multiple player rows in the players table, and one team row in the teams table. You can join these two tables together based on that relationship, i.e. the relationship between the players and their team. MongoDB, on the other hand, is what we referred to earlier as a NoSQL database. NoSQL databases started to be developed in the 2000s, and some popular types are MongoDB, Cassandra, CouchDB, Redis, Memcache, and DynamoDB. They use many different NoSQL methods to query their data, including, in the case of MongoDB, JavaScript, or even HTTP itself for other databases. In their most basic form, like DynamoDB, they are key-value stores, but they can also be graph or object databases, or again, in the case of MongoDB, a document store. While we'll dive much deeper into this later, documents are a very flexible and powerful way to store data, and have many advantages over tables. For example, instead of storing our data in a lot of different tables and joining it all back together, we could have a single team document that has the name of the team, their stadium, and then an array of player objects, which are also documents themselves, with each player's name, their number, and their position, and maybe even an array of the schedule of their games. The teams can then live together in a collection with other teams. To query the data, we use a JSON-like syntax to find the team document with the name Seattle Sounders, for example, here. Due to these differences, there are many advantages of using MongoDB for your next project, and some disadvantages, but some of the advantages include a much more flexible schemaless storage format, high speed and easy scaling, and of course, much more we'll talk about in this course. Next, we're going to talk about using the Git repo that is associated with this course. Okay, let's get started. First thing we're going to want to do is go to the MongoDB website and look for MongoDB Community Server Download. You could also just Google that. We're going to be doing this for the Windows operating system. The current version is 5.0, but this course is also compatible all the way down to 4.2. What we're going to want to do is select Windows and the MSI package and go ahead and download it. Once that is done downloading, we can go ahead and open the file. Once that's downloaded, we can run the installer. We'll go ahead with the defaults. Now we have the option to run MongoDB as a service, as well as pick our data directory. To make this easy, we'll just leave all the defaults again. Next, we have the option to install MongoDB Compass, which is a graphical user interface for MongoDB. We'll go ahead and do that too. Alright, looks like that's finished up. Now it's installed, you can go ahead and load Mongo Compass yourself and connect to the local host and browse around. What I'm going to do though, and throughout the rest of the course you'll see me doing so, is using the command line itself. So to do that, we're going to go directly to where these files were installed, which is generally in program files, MongoDB, if you had kept the defaults, and then server, and then the version, so in this case 5.0, And then there's a bin directory and a data directory, as well as log directory and some other files. This data directory is where the actual data for your MongoDB server is stored. The bin directory will have a number of binary files you can run. Also, when you install the Mongo database tools, then they will live here too. So we're just going to use Mongo exe and we're going to run it. And it will tell us a bit of information here, which is not super important. But what we're going to want to do is see if we have any databases installed at all. So we're going to say show dbs. That'll show that we have 3 databases installed here. Nothing really going on because we haven't inserted anything in them yet. That's what's coming up next. We also want to make note, by default, it's using a MongoDB CFG here. And that's a configuration file for MongoDB for Windows. So if you ever need to edit it or change things, which you may need to do later in this course, that's where it's located by default. Next, we'll talk about installing the MongoDB database tools. All right, let's get started with installing MongoDB for macOS operating system. First thing we want to do is go to the MongoDB website. And here, we'll find a number of different ways we can install MongoDB Community Edition on macOS. It's recommended to use brew, and we'll show that in a second, but you could also go down and find the install files and download the zip file and copy the binary files into a bin directory of your choosing. On more recent versions of macOS, if you use that method, however, you may end up getting a message like this. In this case, you'll need to go to your security and privacy in your system settings, and then go to general, and you'll see a message something like MongoD was blocked from being installed, and you'll need to allow it anyways. The current version is 5.0, but this course is also compatible all the way down to 4.2. Depending on your version, it may also, in this case, install database tools for you, so you could skip that next video if it does. The important part here is we want to use MongoDB Community Server Edition because that's completely free. We can install using brew. The directions here. This may change over time, so make sure to reference the website to make sure it's up to date. First, we'll do a brew and tap MongoDB/brew, and then brew install MongoDB Community. In this case, it's at 5.0. If you want to make sure everything's working fine in this course, go ahead and do that so you make sure you don't have any problems. If you don't put a version here, it will install the latest version. Once that's done installing, you should see a screen something like this. The important part here to note is it has a MongoD --config as an example, or you can run a background service. This background service will run all the time, or if you run it with MongoD and a config file, you can just boot it up each time you want to run MongoD. MongoD is the actual database server. If you choose to use MongoD --config, you can use the included config file in the course repo. So as you can see in the course repo, there is a MongoD conf, and I've created a _data directory. So you do something like make dir data, and then inside that directory, there is a DB directory, and I would make the DB directory so that exists as well. To run MongoD, if it's globally installed, you can simply type MongoD. In this case, we did it inside a bin directory in here. So I'm going to do bin/MongoD and then provide it with a config file. This will be the same either way. And that config file is already in this directory. I provided it for you. So we can just tell it to use mongo conf and press enter. This will boot up and give us a bunch of data. And eventually, it will have something along the lines of accepting connections. That means it's running. Next, let's try to connect. Now, let's go ahead and try to connect. If you installed your files into a bin directory, they may be in a bin directory like this. Or if you installed it more globally, you can simply type Mongo. This will automatically connect us to our database. It's going to have possibly a bunch of information here, which isn't important at the moment. You can just clear that out. What we'll do to make sure we've actually connected and we have some data is type the command show dbs. This will show us we have a number of different databases here. in my example, I have two extras that I've already imported data into. That's what we're going to do next. Along with the database itself, there are a few other MongoDB programs we will use in this course. In versions of MongoDB before 4.4, these binaries were bundled with the standard MongoDB server install. So if you're using an earlier version of Mongo, you can probably skip this video. MongoDB now bundles these tools together as MongoDB Database Tools, and you can download them from the same site we used to install MongoDB Server. If you're using macOS, you can also use brew, which is a little bit easier and is recommended. Simply brew tap MongoDB/brew if you haven't already, and then brew install MongoDB-database-tools. Or again, you can download the zip file. On Windows, you can download the MSI installer or the zip file. You can find these on the MongoDB website with the URL you'll see on the screen. It should auto-detect your operating system and then give you a download link. This will download a zip file into your system. Once you've allowed the open anyway, you can now press the open and allow it to open. It will remember this setting going forward. For Windows, we can download the Mongo database tools here. You can choose a zip file or MSI. We'll choose MSI. Download that. We can launch the installer. Accept the agreement. Now by default, it will install it into MongoDB tools, but we want all our binaries in the same place. So I'm going to go to Browse, and I'm going to switch it to Program Files, MongoDB Server in the version, and it will install things into a bin directory, so we'll just leave it there. Now, it will install into the bin directory in the 5.0 directory. Once that's done, we should be able to go in, browse, go to our C drive, Program Files, MongoDB, Server, 5.0 version. We should now have a couple of other binary applications we can run, along with Mongo and MongoD. For example, Mongo Files, which we'll need later, and Mongo Import that we'll need to import the files. We can run MongoStat to test it. We should start getting some output here, which means it's been able to connect to our local host successfully. And there you go. Next, we'll talk about importing the example data into our database. Now that you have MongoDB Server and client installed, let's import some example data that we'll use throughout this course. There are a couple different ways you can import data into your MongoDB Server, but here I'm going to show the most basic using Mongo Import, and also using the Mongo Compass GUI. If you didn't install MongoDB database tools already, which includes Mongo Import, make sure to go back and watch the video on how to do that. First, inside our course repo, we're going to look for a collections folder. So I can see that right here. And I'm going to open that just so we can see what's inside. In here, you'll see a README file, as well as 3 JSON files. Those are going to represent the data we're going to import. So real quickly, we'll just open this up, and we see this is a JSON-looking file with a lot of data in there. More on that later. So what we're going to do is find where our Mongo import is. So in this case, I have it in a bin directory. So I'm going to go ahead into the collections, and then I'm going to use the Mongo import from that bin directory. So Mongo import. Depending on your installation, you may just be able to just type Mongo import or Mongo import.exe. But in my case, I put the binaries in a bin folder in the course repo. So the next thing we'll need to do is show the database. So we want to import this into a DB called Cooker. And then next, just because of the way I exported this data, we're going to want to add this extra option, JSON array. And finally, the name of the file we want to import, recipes.json. Now, you'll see we didn't include a collection name here in the file, but that's okay, because as you'll see, no collection specified, so it uses the file name recipes as the collection name. And it imported 7 documents successfully. That's what you should see, so that's perfect. Next, we'll import the 2 other files in here. So there's an examples.json, and that should have 3 documents. And then a users.json, and that should have 2 documents. Awesome. So now we could connect to the MongoDB server and we can actually look to see if everything's gone in correctly. So from our bin directory, again, it depends on how you install this, but all you'll need is the command mongo. And don't worry if it tells you anything like that. What we'll want to type is show dbs. And you'll see there is a cooker database here now. And if we use cooker and then tell it to show collections, you'll see there are now 3 collections in here, including the most important one for us later, called recipes. Great. So another method you can use to import the data is the MongoDB Compass GUI. Now, you can go ahead and look up the directions how to install this if you want to use it. You'll see this is showing us it has a cooker database here, and inside here it has our 3 collections. So I'm just going to go ahead and create a different name database, but in your case, you'd press create database. You'd name it cooker. I'm going to name it cooker 2. And then it needs a collection name, which will give it recipes. And we'll create that database. And then once we go in here and refresh that, we should see a recipes collection that's empty. And we can press either this import data or add data here. And we'll need to select a file. That's going to be that same file we just used. So recipes.json from the collections folder. And we'll press JSON here for the type. We'll import, should say 7 out of 7. And there are our documents of all our imported data. So now that we have all the data we need, we can go ahead and continue to talk about how we query for this data. So what exactly are documents? Simply put, MongoDB documents are field value pairs stored in a JSON-like format called BSON, which stands for binary JSON. So, what are you waiting for? Let's create some documents and save them to our database. What I'm going to go ahead and do is go into our course repo and go in the lessons folder, and so lessons /2.1 for this lesson. And in here you can see there's a recipes.json file. I'm going to go ahead and open this in VS Code because it's going to format it for us nicely. You can see something that looks a lot like JSON because it pretty much is JSON. On line 2 here, we go ahead and start with the title of a recipe for chicken tacos, as well as a description and a cook time. You can see these 2 are strings, and this one is an integer, and they're all wrapped in these curly brackets. So there can be multiple key value pairs, and they can actually be all kinds of different data types. Strings, arrays, objects, more than that in a future lesson. Let's go ahead and start inserting some documents into our database. So I'm going to go ahead and load up Mongo. Now this is the Mongo Shell command. It might throw some warnings at you here. Don't worry about them. You can just clear them out of the way. If you had any problems and that didn't load up, make sure to go back to the install video where we learned how to run the MongoD command to launch MongoDB server. Once we're in Mongo, we'll get a MongoDB shell. One important thing to know is this is a JavaScript shell. We can literally write JavaScript here if we want. But first, let's connect to the right database. Again, make sure to check back to the install videos if you haven't imported the example databases yet. So we're going to go ahead and use the cooker database. And we'll do much like we did in the code editor, but here we'll assign the document to a variable. So let's just call it doc. We could actually call it whatever we want. We'll give it a talk title and the title of tacos. And we'll add a description here of yummy tacos. And we'll give it a cook time as well. And let's say that cook time is 20 minutes total. And we're going to close it out right there. And it's going to spit back something here. This means it worked correctly, and it'll give us a nice formatted version of it. Now, a document is a lot like a row in a SQL table, but it's way more flexible. So the next thing we'll do, Now that we have our document ready, we'll need to insert it into a collection. So the way we do that is db dot whatever our collection name is, just call this tacos, and then we're going to use this insert one command, and we're going to give it our variable, and it's going to tell us it properly inserted the document. If the collection didn't exist already, it's actually automatically created for you. More on collections later, but they are kind of analogous to tables in SQL. Now let's go ahead and see what our document looks like. So let's do db.tacos.find. And we'll get back our document with the title, description, and cook time, but you also notice this other field here, this underscore ID. That wasn't in original document. The underscore ID field is required in every document in MongoDB. And while you could supply your own, it's better to let MongoDB auto-generate one like it did here. Not only will it make sure it's unique, which it has to be, but also it actually contains an encoded datetime for you, which is really useful for sorting. Anyhow, back to our document. There's also a little trick here that we can use on find, and we can put this pretty at the end, and it will give us a nicely formatted document. And one more trick, if you press the up arrow in the shell, you'll see we can get back previous commands. So if we wanted to assign another taco, let's just call it document2 and we'll call this dos tacos. And then we can press up till we find that insert one command. We'll change the variable here to doc2. And then we'll run the find pretty. We'll get back two different documents, our tacos and our dos tacos. In the next lesson, we'll talk more about find and how to query documents. The find command is one of the most basic MongoDB commands and acts much like a select statement in SQL. Let's learn how to use find to query our recipe documents and find specific recipes. The first parameter for find is a document. Not the document that you're trying to match, but rather a query document. If you pass an empty query document, then it'll match all documents. The default is an empty document. For example, if we do db.recipes.find and don't pass anything, we'll get a whole bunch of stuff back. If we ask for something specific, like where the title is equal to tacos, I will get just one recipe back. Now, to make that look a little nicer, I can add on to the end an extra little command called pretty. And now this is formatted in a much more readable fashion. We can also do conditionals. So if we wanted to match more than one thing, for example, not just the title, but also the cook time being 20 minutes, we'll get back our document again. Now, I happen to know that took 20 minutes, so if we change this to 19, we won't get any results back. Just again, no results back, because nothing matched both and tacos and 19 minutes cook time. Sometimes the document might contain a lot more data than you need for your purpose, as you've kind of already seen. By default, find will return all document fields, much like a select star. But if you want to specify or narrow down the fields you want to return, you need to provide a second parameter to find. So in this case, let's switch it back to just looking for tacos. And as a second parameter here, I will add title again, and I'll put 1 for true. So this is going to mean I want just the title back. When I enter that, you could see I just get the title back. You can also exclude fields. So instead of a 1 here, I can make that a 0, and it will bring me back everything but the title. To get back all the documents with just their title, you could send an empty document in your search. So I'll just write that out from scratch again. db.recipes.find and an empty query document. And then title equals 1. Now I just got back only the titles for my recipes. It's a little bit easier to manage. But what if I need to search by a partial title? After all, a user of our website is unlikely to type out the exact recipe name. To do that, we use wildcard searches. It's akin to like a like statement in SQL. However, instead of using the %sign, we use regular expressions because remember, we're using a JavaScript shell in MongoDB, so we can use regular expressions just like you would in JavaScript. For example, we could do db.recipes.find, and this time it's going to look very similar. We're going to ask for title, but we're going to put another bracket here, and we're going to use this $regex and a slash. I'm just going to write a regular expression here and an I here for case insensitive. And then we're just going to close out our result here. And you'll see we get back two different documents. Actually, it's kind of hard to see. So let's use one of the tricks we learned earlier. So we have our query here, and I'm going to give it a second parameter of just title equals 1. And now you could see it brought back two different recipes, chicken soft tacos and tacos. In case you're wondering, we can also do searches on numeric ranges with greater than or less than or queries, lots of other stuff like that. We'll cover those in the next section. Next, we'll talk about what we could store in documents. MongoDB documents can store a wide variety of data in a number of different formats, which often makes development easier. So far, we've mostly worked with text or number fields in our documents. These are much like the basic types you might be used to in a relational database. But what if we want more flexibility? Take this recipe, for example. When we think about it, a recipe contains a lot more than just text or number data. In fact, it has a lot more structure and detail that we can see on the printed page and categorize in our minds. But how do we store it? Sure, we could just copy and paste lists of ingredients and the directions and store them in a large text field, but then we lose a lot of granularity and options for what we could do with that data later. For example, what if we need to change the measurements from imperial to metric, or change serving sizes? In a traditional database, at this point, you'd need to start thinking about refactoring this data and about normalization, denormalization, etc. With MongoDB, we don't have to do that. With MongoDB, we can mix and match data types together and pretty much store this recipe exactly like it is on the page, but also in a way that will let us do really powerful things later. At this point, you might be really starting to understand why they call these documents. Let's start with the directions. There are steps, and the order matters, sort of like an array. To see how we could store this, I'm going to open up some example files I put in the lessons/2.3 directory. In here, you can see there's a directions.json and ingredients. I'm going to go ahead and open these in VS Code so they'll format it nicely. You can see with the directions, we have a title, and then I've just actually stored a flat-out array for the directions. Roll the pie crust, make the filling, bake. Of course, real directions would be different than this, but of course this is just an example. We can literally represent this with the JavaScript style array and store it in our document. Now, let's move on to another part of this recipe, the ingredients. Over ingredients.json, you can see I've expanded on this document. We still have our title and our directions, but starting here in line 8, we have ingredients. And again, it's an array, but this time, instead of an array of strings like the directions, it's an array of objects. Not only that, that object has objects inside this. You can actually think about this as its own document itself. The nice thing this lets us do is store our ingredients in their units together yet separately, so we could, for example, change the serving size or the units of measure later. As you can imagine, there are a number of ways to do this. This is just one example. I'll also open up a more complex example of this. To do that, I'm going to use MongoDB Compass, a free GUI from MongoDB. You can see the links in the lesson notes for more on how to find this. This one is a full-fledged recipe. It has a title, calories per serving, cook time, a description, directions in an array, ingredients in a more robust object array, has likes, like count, ratings, etc. We're going to talk about how we can start organizing some of these documents into collections. Lastly, let's show inserting a document that we want to create. So to do so, we can use the insert or insert one or insert many, but for this example, I'll use insert. So in this test collection, I'll use insert one, and we'll give it a document to insert. So we can say title, test, doc, and that's it. We'll just have one document with a title. And it will say acknowledge true that it inserted, and it gave us an object ID, which will be the object ID of the document that was just created. So if we do test.find, you'll see a document with a title of test doc and the auto-generated object ID for your underscore ID value. While the flexibility of MongoDB's document model has many advantages for developers, keeping those documents organized can become trickier. That is where collections come in. As we store more and more of our site's data in MongoDB, inevitably some of that data will be distinctly different. Take these documents, for example. We have a recipe, a blog post, and a user account. Now, we could store these all together by having maybe a type field and marking it as recipe or post or user. But at some point, that's going to not only become somewhat annoying, but it can cause performance problems. With collections, however, we can keep related documents grouped together for simpler organization and better performance. You can think of collections somewhat like tables in a relational database, but not all the documents need to have the same schema or structure. The collections themselves are then stored inside databases, which we'll get to shortly. We've actually been using collection all along. It's what we've been using after the DB in our queries. For example, if we do db.recipes.find and ask for all documents, and then say we just want the title back to keep this a little more clean, this gives us all the documents that are in our collection. Now, there are some commands that you should know to help us with collections and databases. For example, we can do the show dbs command. This will show us all the databases in our MongoDB instance. We can also use show collections. This will show the collections inside whatever database we're currently in. If you need to know what database you're currently in, you can use db.getName, which will let us know we're in the Cooker database. Both databases and collections are created as you use them, i.e. insert data, so it's really simple to create them. For example, if I wanted to create a brand new collection, I could do db.cool new stuff and insert something. So in this case, I'm going to insert just an empty document. And as you can see, it inserted one. And if I do that show collections again, now cool new stuff exists as a collection. I didn't even have to create it, it just got created for me. They can be named pretty much any UTF-8 string with the exception of blank or null. Those are not valid collection names. So now we can store our recipes with our recipes, our users with our users, and our blog posts with our blog posts. You can also create subcollections using a dot, like this. Say instead of cool new stuff, we did cool.newstuff and insert one. Now when we look at our collections, we'll see a completely different one. Now, this doesn't actually store your data any differently, but it can be helpful for query purposes. There are also other collection options like cap collections, where we can tell MongoDB to only store a maximum amount of documents at any one time, and will automatically delete the oldest document in the collection to make room for a new one. We'll cover more advanced topics like that later in this course. Next, we'll use what we've learned so far to complete a challenge. Alright, it's time for our first challenge. For this challenge, you'll need to use a new collection, create a new document for a recipe, and that recipe should include, at a minimum, certain fields. It should have a title, a description, a star rating, a food type tag, a user comments section, so that could be an array of objects, for example, and optionally, directions and ingredients. You can look at some of the examples in the recipe collection for this, but see how much you can do from memory. Good luck! In the next video, we'll show a solution to this challenge. So hopefully you found this challenge pretty easy after everything we reviewed. To solve this, we use a combination of strings, arrays, and objects. I'm going to open up an example document I've already created in VS Code. Here, we can see the title as a string, the comments as an array of objects, and here I've used a special date field, which you can look up on your own. We also have the directions that are also an array, but this is an array of just strings that are comma separated. We also have ingredients, which is an array of objects as well, but we'll close that for now. We have star ratings from 1 to 5. Doesn't look like many people like this recipe. We have tags to describe this recipe, and also a dessert type. So we can literally just copy this whole document, and by way of example, I'll open up Mongo Compass to show actually inserting it. So we'll go to our test solutions collection, and we'll go to insert document, and literally just paste our document here, and we'll insert it. And there we go. We have a new recipe in here, and it has all our special data types, and we're all good. So go ahead, keep messing around with this, try to get comfortable with it, and in our next section, we're going to be talking about querying MongoDB. When querying a database, making sure to limit the amount of data returned and sorting it properly is key to better performance of both your queries as well as your overall application. So, how do you limit, sort, or skip documents in your queries? When you request documents back from MongoDB, under the covers, the database returns back what is called a cursor. Technically, when you run the find command via the shell, or the driver in your programming language, even though it is sent to the server, it actually doesn't run right away. Instead, it waits until the results are requested back. This happens automatically unless you manually iterate on the cursor, but it is important to understand nonetheless. While this might not seem like a huge difference, what it allows you to do is add extra commands after find to do what is called chaining. If you've ever used a JavaScript framework like jQuery, you are likely very familiar with this concept. The order of the items you chain together doesn't matter, but how they change your results matters a great deal. One of the most basic query options you can run is limit, which, as this name implies, limits the number of results returned. To illustrate this, let's look at our recipes collection. And we're going to do a find for all documents, and we're going to request a count back. We'll see that there are 7 recipes in our collection. To make this a little easier to see, I'm going to change this to request all documents back, and then just ask for the title field, and just remove the count altogether. Now we'll get a nice clean listing of our recipes. Now if we want to limit those results, we simply add on this limit option. So now we've gotten 2 or 3, etc. Another very common query option is sort. Now sort will take a document in itself, where the key being the field you want to sort by, so let's say title, and the value being which direction. So 1 meaning ascending, -1 meaning descending. So if we do this now, we'll get all the recipes back with apple pie at the top and zucchini brownies at the bottom. So if we do -1, we get zucchini brownies first, apple pie at the bottom. Again, if we want to limit this, we could do ascending.limit and only get 2 recipes back, but now it's alphabetized apple pie, brown sugar meatloaf. A less used but sometimes useful query option is skip. So let's keep it alphabetized for the moment, and we'll say I want to skip 1 document. When I do that, apple pie is gone and brown sugar meatloaf starts off the list of our recipes. You can chain together many of these commands, as you kind of already noticed. So if I want to skip 1 and then limit 1, I get brown sugar. If I skip 2 and limit 1, now I have chicken soft tacos, and you can see it will go along our recipes in alphabetical order. Next, we'll talk about different operators you can use in your queries, and also how to query data that is stored in arrays. MongoDB has a number of operators that can be used on your fields, be it a string, number, array, object, or subdocument. We can use these to conditionally filter our results. Most of these operators will likely work in a familiar way, but how they look may be slightly odd at first. Since MongoDB uses a JSON-like syntax for its queries, using some traditional operators like greater than and less than won't work. To avoid this problem, the query language uses strings with a $sign in front of them. No, this has nothing to do with money, but once you have some of these down, you will be able to write much richer queries. How does this work? Well, for example, instead of greater than, we have $GT. And instead of less than, we have $LT. And instead of less than or equal to, we have $LTE. By the way, to follow along, you'll want to make sure you import the recipes collection via the recipes.js file in the course repo. Now, let's imagine we need to add a new feature to our website called Quick Meals. To do so, we want a query to find out all the recipes with a cook time of less than or equal to 30 minutes. We can do that with a query like this. We specify the cook time, our $LTE, and 30 for minutes. Now we get back all the recipes that will take 30 minutes or less to cook. Now that's fine, but there's also prep time. So let's add on checking for prep time of 10 minutes or less. We can do this, which is equivalent to an AND query, by simply adding a comma. So here we have our cook time again, and comma, prep time, and our prep time less than or equal to 10 minutes. You'll see now we have 3 recipes that came back. If we are wondering why smoked salmon is now gone, we could simply query that recipe directly, and we can see that its cook time is 20 minutes, and its prep time is 15, which exceeded our query's limits. We can also do an OR query by prefacing our conditional with $, or, and we put our two filters inside an array. So we have our cook time filter and our prep time filter inside this array. In this case, we'll get 4 documents back. So, what about arrays and objects? For this, let's take a look at our tags array, where we have some useful information about our recipes. For example, here we see our tacos are Mexican, quick, easy, and ground beef, or apple pie is traditional and 4th of July. If we want to find all the recipes that were tagged with easy, we can simply say tags easy as our filter, and we'll get back 4 different documents that all have easy in them somewhere in their tags. But what if we want easy and Mexican? At this point, you might be thinking you can just put that inside an array or something like this. I want to find all the tags, easy or Mexican, but we get no results. This won't work because Mongo will see this as an exact match for the array and try to do an exact match on the arrays in the documents. So in other words, you'd have to send the entire contents of the array to match. Instead, we need to use a completely different operator in this case, all. So we say tags, and we put inside another document, all, and now we can put our array of easy and quick, and we will surely get back 2 recipes. On the other hand, if we want recipes that are easy or Mexican, we can use the in operator. So same thing as before, but instead of all, we're passing in. And we'll get 4 recipes this time. Lastly, if we want to reach inside the data of an object or an array, we use dot notation. For that, let's take a look at the ingredients field. Here, we have a complex object that has the name of our ingredient and quantity, etc. Now, if we want to get back all the recipes with eggs in them, we could simply use dot notation like so. Ingredients, dot name, and egg. And we'll get back 2 different recipes, pancakes and zucchini brownies. Now, just by way of illustration, if we deconstruct this slightly and ask for ingredients with an object inside name with the value of egg, which you think might work, this won't. Because again, it's the same problem as before. It's looking for an exact match. So we need to write out the whole object's or array's contents for that to work. So remember to use dot notation unless you want an exact match. There are many other operators you can find by checking out the official MongoDB docs, and there's also some links in the README. Next, we'll talk about how to update and delete documents. At some point, your data is going to need to change, be it because you decide to change your schema, a user updates their profile, or the most likely reason in my case, one of our recipes is a spelling error. For this lesson, I'm going to be using the examples collection, so we don't mess with our recipes data. You can find an examples.js file and directions how to import this collection in the notes and in the course repo. Most of the time, you just need to update a single field in a single document. To do this, we can use update1, along with a couple of update operators. Here, we will cover set, unset, and inc, as in increment. On the other hand, the update command will update multiple documents, but works basically the same way. By the way, Mongo also has a concept of an upsert, which will update or insert depending on if a matching document or field already exists or not. You can see a link in the docs to learn more about this. To update a field, we can use the set operator. First, let's get a list of our recipes from our example collection. Here we can see 3 different recipes. Now, say we want to change the title of this pizza recipe to be more descriptive, because it's actually a thin crust pizza. Well, we can do that by running db examples update 1, tell it which document we want to update with this filter, and we want to update the one called pizza. And as a second parameter, we're going to give it the set operator and tell it what we want set to do. So in this case, we want it to change it to thin crust pizza. And we'll close that out. And you'll see it matched one document and modified one document. If we get our listing again, you'll see this is now called thin crust pizza. In this case, we use the title as our filter back here. But we could have used underscore ID, for example, if we want to be more specific about which document we're updating. If you run set on a document that doesn't have that field already, it will insert it. Remember that upsert idea? Well, let's go ahead and try that now. First, let's find that document as is. So we'll just do a quick search here. Well, I'll clear this out. Do a quick search here for thin crust pizza. We can see this document just has a title in it right now. Let's bring back up our update and we'll change this around a little bit. So instead of title pizza, since that will no longer match, we'll change that to thin crust pizza. And instead of setting the title, we are going to add a field called vegan, and we're going to make that false because this pizza has meat on it. Now, again, it will tell us it's matched a document and it modified a document. And if we look up this recipe, we'll see the title is thin crust pizza and it now has vegan false on it. If we no longer want this field on anymore, we can use the unset operator. So the same as this, set, but we'll change it to unset. And instead of setting the value of what this field will be, we'll just tell it use this field, vegan, and we'll put a 1 for true. So that means unset this field. And when we do that, we see the field is gone. Cool. Now, what if we'd like to do something like easily increment a field without having to know the value of that field at the time the query ran? I'll tell you more in a second why this could be really important. To do this, let's go ahead and check out the example tacos recipe. So title tacos, and I'll just print it out pretty here. You could see, as you look through this, the document is a full-fledged recipe like we've been working in earlier. You also see there's a likes array and a likes count, which is a pre-calculated count of the number of items in that likes array. Now, what if we need to increment that count field by 1? In other words, simulating another user liking the recipe. Well, we can do that by using the inc operator. So the way that works is very similar to the set, but instead of setting a field, we'll still give it a filter of what document we want, and we'll tell it to increment. And we'll tell it which field to increment. In this case, it's the likes count. And we'll tell it by how much. So this could be 1, it could be 10, it could be 1,000, it could be -1, but it will be whatever we want to increment the value it currently is by. We'll go ahead and close that out. Now when we search for this, we'll see our likes count is 3 instead of 2 as it was before. Again, if I run this command again, make it -1, search for that, our likes count is back down to 2, which matches this, so let's just leave it that way. Doing it this way can be very useful as it guarantees what is called eventual consistency. The database will make sure that field is always increased by, in our case, 1. To understand this better, imagine if 3 users liked a recipe on your site at the exact same time. So in this case, say the initial line count was 10, then the count should end up being 13. But if any of those queries tried to check the like count in the array and update that count field, you risk the final count being completely wrong. With this atomic operation, however, you never need to worry about that. Keep in mind, by default, there aren't any locks or transactions on queries. Next, we'll talk about updating and modifying arrays. Working with fields that contain array data means we will need to use some different operators, push and pull. To add an item to an array, we can use push, which will push an item to the end of the array. So let's start off again with our tacos recipe. And look again at that likes array. So there's 2 items in it, 2 user IDs. Let's go ahead and push another user ID into that array. So we could do db examples, update 1, tell it we want to update where the title is tacos. And as the second parameter, we're going to say we want to push something into the likes array. And in this case, let's add ID 60. And then we'll close that out. You'll see it matched one document, modified one document. If we run our find again, you'll see there is now a 60 added in our likes array. If we wanted to remove that, we can simply use the pull operator. So instead of push here, we can just change that to pull. It will again acknowledge it updated correctly, and you can see that it is gone from that likes array. Now in this case I used an int, but it could have been a string or an object or even another array, whatever's valid in there. There are also a number of other array operators you can use. You could see the link in the lesson notes for more. Next, we'll talk about how to delete documents. Updating documents is great, but sometimes things go really bad, like things get really messed up, or you just need more disk space. So you'll need to delete documents. We have 2 basic options, delete one or delete many. Both take a filter document, like find and the update commands. For delete one, the first matching document in the collection is deleted. For delete many, all documents that match will be deleted. Obviously, if you're writing a query that you expect to only ever delete a single document, use delete one to be safe. You can provide the _ID or any other sort of filter. Let's take a quick look at the documents in our example collection. Now say we want to delete this delete me document. We could look at the object ID here and delete it. So delete one, and we'll tell it I want to delete one that has the object ID here. And oops, got an extra parenthesis. And now that, close it out. Now it acknowledged it deleted one. If we get the list of our documents, now it's gone. Now we could have also made a filter check, for example, the likes count for any documents that have no likes. Next, we'll have another challenge, combining some of the skills we've learned in this section. Well, it's that time again. Another challenger appears. Okay, so in all seriousness, let's get your fingers to typing and use some of the concepts and skills we've learned so far. Your mission, using the provided recipes collection, or if you want to use your own data, feel free to adapt this if that's your thing. You have 3 tasks. First, we need a query that will bring back the top rated recipes, 5 being the highest rating. Base that off the ratings array, but hint, explore the schema of the documents and you'll probably see a ratings average field with the average already compiled for you. Use this to order results by the most popular, limited to 4. You can pause the video now and try. For challenge number 2, once you have done that, write a query that uses the tags array field in our recipes to bring back the recipes tagged with Mexican, still ordered by top rated and limited to 4. Go ahead and give it a try. And the last challenge, write a brand new query that gets back all the recipes liked by user ID 1, sorted by the title with no limit. Take a look at the likes array for this one. In the next video, I'll show you one way to write these 3 different queries, and you can compare with what you've come up with. Were you able to complete all 3 challenges? Did you just skip ahead to this video to see how I did it? Either way, let's see how to solve these challenges. First, for number 1, we could do a way more complicated query and try to figure out the average ratings from the rating array for each recipe, but hopefully you got my hint and used the rating underscore average field. So to do this, we can write a query like this. We'll go ahead and find all the recipes, and I'll request back all documents, and I'll just get back the title to make this a little more clean. And in this case, all we really need to do is sort. So we sort by the rating underscore AVG, and importantly, you want to do a -1 to get descending, so we get the highest rated first. And then we simply limit by 4. And we have our top 4 recipes. I bring this up specifically because often it may make sense in your documents to have a separate field like this rating AVG that pre-calculates things like counts and averages. If you checked out the document, you'll also see there's something similar for likes. So just keep that in mind. Second, for this challenge, we need just a slight change to the query we just wrote. Instead of asking for all the recipes with no filter, we'll add a filter on tags. So in this empty document, that will now become tags and equal to Mexican. Now we'll get back the 2 Mexican recipes sorted by how popular they are. Now, for the third challenge, we're going to have to write a completely different query. But before we write that query, let's get back and look at some of our documents a little more closely. So I'm going to go ahead and find, again, all the documents and just the title. And I'm also going to ask for the likes array. So both of those are set to 1. And I'm going to sort by the title. Okay. Now, as you can see, each of these have some likes, except for poor zucchini brownies. I guess no one likes those. So these have the user IDs here that liked each recipe, and each of these is slightly different. Now, if we want to solve the challenge, we need to use an operator. We need to use the operator all. So I'm going to start from scratch again here and do recipes find. But instead of asking for all documents back, I'm going to say likes and open up another document here and say all. And I'm going to give it an array, and I'm going to put 1 in there for user ID 1 and close that out. And just ask for the title again here and close that, and sort by the title as well. Now we got back all the recipes that are liked by user ID 1, ordered by their title. Just to show this is working, let's clear that out. Okay, so that's user ID 1. We'll change 1 to 35, which is a different user. And you'll see they only liked one recipe, pancakes. Now, if we put in both 1 and 35 here, we'll still get pancakes only. And that's because user 1, while they like these other recipes, the only one in common is pancakes, because this functions like an AND query. If we want to switch this around to get all the recipes that either of these people liked, we would need to change all to in. And now we get all 5 recipes that are liked by either of those individuals. In the next section, we'll dig into data and schema modeling with our databases. Throughout this course, we've used the Mongo shell command. That's the default shell, and it works with all versions of MongoDB. However, MongoDB has also released a newer version of the shell that will eventually replace Mongo, called MongoSH. So let's review that a little too. You can download MongoSH from the MongoDB website, just like you did for MongoDB server in the tools. Or you can use Brew if you're on a Mac. By default, like Mongo, it will connect to your local MongoDB server. Or you could specify a connection. So let's go ahead and run it. And you'll see it's connected to my local MongoDB server. So far it looks a lot like Mongo. And let's go ahead and use our cooker database. MongoSH has a couple of helpful improvements on the shell. For example, if you need more info about a command and you don't want to look it up, you can add help to the end of it. Like for example, if I was in my recipes collection and I wanted to create an index on it, but I couldn't quite remember how the right command was, then we can add help to the end, and it'll give us an example of how to create an index, as well as a link to the documentation. Another nice new feature is highlighting. This works both when the data is returned and when you're writing a query. For example, if I'm querying my recipes and I wanted to find one where its title is taco, then you'll see it's already nicely color coding this query for me, so it's a little easier to see what I'm typing. And you can imagine when you're writing a much longer query, that's very useful. The results are also color coded and formatted, so I don't need to add the pretty to the end as we've done earlier, and we get this automatic color coding, which is pretty cool. Lastly, this is all based on a Node.js environment, so you can go beyond just JavaScript. For example, we could assign the results of a query to a variable. So let's just call this results, and we'll do db.recipes.find, and I'm just going to return all the documents back because there's only 7 of them anyways, and then we're going to ask for the title back and the prep time. Note, you could put these in quotes if you want, and it'll just highlight it slightly differently. And we're going to say we don't need our ID back, so we'll make that 0. And then we're going to turn the results of this to an array. So it's just standard JavaScript there. And now we could do console.table, and we could put our results variable inside it. And now we get a nice formatted table with our results in there, which makes it a lot easier to read. Additionally, there's autocomplete. So if I am writing a query here and I say recipes.find, and I'm gonna say go on the cook time, and I know it's like I want like a greater or less or something. I can't quite remember. If I press tab there, it's going to tell me there's a possible command that's GT or GTE. for the time, and if I take that away, I'll actually get a couple more options here. These geo-coordinate ones aren't going to be very useful in this case, but that's just an example. There's also a built-in editor for writing scripts, optional snippets and extensions you can use, and a lot more. So if this looks cool to you, make sure to go check it out. Next, we'll talk about data and schema modeling. So far, we've talked about how to create a document and how to query documents, but we haven't really talked about strategies for data modeling. Since we're dealing with a different type of database, we need to think differently about how we store and model our data. As Vigan Jan from MongoDB likes to say, data that is accessed together should be stored together, meaning if you're going to be reading or writing data together, it is usually a good idea to store them together. Instead of storing data in two different places, you should be thinking about how you might be able to embed one of those pieces of data inside the other. This should have you thinking differently about traditional one-to-one and one-to-many relationships. Also keep in mind what is more likely in the case of your data. Take, for example, the likes in a recipe document. It is an array of user IDs. These could also be object IDs. And while there might be thousands of likes, there will most likely be hundreds or less. And since we're just storing an ID, in most cases, an array will be great for this. We store likes with the recipe because we want to show the likes when we display the recipe. It reduces reads and queries. But what about a feature like the ability for a user to save recipes? For this use case, it probably makes more sense to store that in an array inside the user document instead. Why do I say that? Because the data is more linked to the user than the recipes. We have no need to search all the recipes to find ones with the user ID in a saved recipes array. Instead, here we're having a saved recipes array inside the user document. We even went so far as to keep the recipe name in there so we can display that without querying for the recipe itself, since the title is unlikely to change. Of course, your use case may differ. Same goes for ingredients. While it is more complicated data, since it's an array of objects, the number of those objects has an upper bound, the max number of ingredients, in other words, that is well within a reasonable range. The reason I mentioned reasonable range is you do want to keep in mind that your whole document will be loaded into RAM when it's accessed. So if one of those fields is going to have a huge amount of data in it, you might want to split that up. More on that later. Take another example, addresses. In a relational database, you'd likely have a users table and an addresses table, and you'd probably have another table that would link the address and the user. With a document model, you can handle that very differently. Since the address only applies to the user, you can embed the address using a subdocument in the user document. This makes sense because you're almost always going to read and modify the user's address in the context of the user. So by storing it together, you not only simplify things, you reduce queries. Sometimes, however, references make more sense. Let's take a very different example. If we have information associated with something that is rarely read at the same time, for example, like something a user would click on a page to load it. Okay, like say we had some ridiculous feature our bosses asked for, like music to listen to while cooking, and we store song data and lyrics and cover art and all that. This makes sense to store separately, as it would rarely be read or written at the same time, and thus reduce, for example, how much RAM we use. If you are doing this though, you should probably consider using unique indexes in both documents. So far, we've mostly been talking about one-to-one relationships. What about one-to-many? One-to-many would be something like a recipe and its comments. There's one recipe, but many comments. If our site is really successful and the recipes have lots and lots of comments, perhaps even threaded, we might not want to store all those comments inside the recipe document. Instead, we could just store the comments in a separate collection of documents, but we could still take advantage of MongoDB to optimize the data and performance. If we change our UX so that the page loads with a recipe with top comments, and the user can optionally press a See More button to get the rest of the comments, we could just store the top comments in the recipe and leave the rest in separate documents. This can improve performance dramatically, since on initial page load, and under most use cases, you only ever query your recipe document. You do want to keep a few things in mind though. Part of the reason we'd store things this way is that it is unlikely a user is going to ever need to see all the comments they've ever made, so we don't need to store this information with a user. Instead, it is most likely a recipe needs to show all the comments made on a recipe. And those comments aren't going to change. But some things can change. Take a user's information, for example. If you store this as part of the comments, and you want to show a full name and a profile picture, these things might change over time. So you'll need to keep that in mind and either store that data slightly differently or have a process to update it. You could, for example, store just the user ID and the comment and get all the user IDs and do a query to the user collection, so treat it more like a join. But you could also store some basic information about the user, enough to load the comment, and then after page load, make a query to the user's collection and update that via AJAX. And then you can add in your profile image. Well, that was a lot. So once you have your data model sorted, the next most important thing is indexing. We'll talk about that next. Indexes. Or is it indices? Anyhow, index early, index often, that's what I say. Seriously though, having at least a basic understanding of indexes can and will help your application perform at its best. While this topic can get very deep and complex, the basic idea of indexes is very simple. Just like an index in the back of a book, an index in a database will allow a query to quickly look up where some information is in your database without having to read or scan the entire book. Even computers need a little help sometimes. So, let's start with a query here to find out how indexes in MongoDB work. I'm going to do a simple query on our recipes collection to find any recipes that have a cook time of 10 minutes exactly. So I'll do cook time, 10 minutes, and let's just ask for the title back only. You'll see one document comes back, pancakes. Now, let's add another command to help us see what really happened under the hood. So we'll keep our same find query here, but we'll add to the end a command, explain. And we need some extra information from explain, so we're going to ask for the execution stats. Now, this is going to bring back a bunch of stuff that we're not going to cover here. The important part here is under execution stats. You could see a total docs examined is 7. Now, there are 7 recipes in our database, so that means the query had to examine all the documents in our collection. Imagine if we had 10,000 or 1,000,000 documents. Well, that might not be so great. Let's try another query real quick, and we'll also run explain on it. So here, we're going to look where the title is tacos instead of prep time, and then we're going to ask it to explain and give us the execution stats. Again, we'll scroll up here to the execution stats, and we'll see total documents examined is now 1. Well, how did that happen? Simple. Title already has an index on it. As an example, I created an index on this field. If I hadn't done that, this would have read total documents examined 7. So we just increased our performance on our query dramatically. Again, imagine if we had 10,000 recipes. We'd have avoided 9,999 recipes with one simple index. We can get some information about the indexes we have in our collection by running a special command. But first, let me show you a little trick. If we do db.recipes, our collection, and then press tab twice, I'll get a list of commands I can run on my collection. Now here my font's really big, so it gave it to more. So I'm going to have to press spacebar to find what we're looking for here, which is there's a get indexes command. And in fact, there's also a get indices, in case that's how you like to pronounce it. So let's go ahead and run that, get indexes. You can see we have two different indexes. The first one is the default index created by MongoDB itself. That's on the _ID field. And the second one here is on the title field. And you also see it's unique. More on that later. And it's called title_1. That is how the query was able to jump right to the right document when we had a search on title. So, how do we create an index? Well, if we had looked at that listing earlier, we would have seen there's a db create index command. And here, we'll just tell it what we'd like to create our index on. So since we were doing cook time before, let's go ahead and tell it to do cook time. And then you need a direction you want the index to go. This is exactly like how sort works with ascending or descending. So just for fun, we'll make it descending. And now it tells us it created the index. And sure enough, if we run get indexes, we have a third index here. And it's called cooktime -1. That's the default name. You could actually give it your own name if you want. The order here doesn't actually matter a ton, but you should try and match how your queries will most often be run, be it ascending or descending. Now, if you run our query again, let's go ahead and do that. Again, on cook time, 10 minutes, and explain that. If we scroll up, we will see that the total documents examined is now 1. Success! Now, to remove an index, we can use the drop index command. For that, we're going to need the name of the index. So again, let's run our get indexes. And you may already remember the index was called cooktime -1. And we can simply run db.recipes.drop index. And in just single regular quotes here, the name of the index. And it will go ahead and drop that. If we run get indexes again, we only have 2 indexes. There are a lot of options on indexes, like unique, which will make sure any 2 documents can't have the same or exact same field or any values twice, or compound indexes that can have 2 or more fields in them, and even geospatial indexes, and a lot more. But the important bit to remember is to examine the queries you are running, especially if you're running them often, and make sure you have proper indexes on those fields. Next, we'll talk about how we can store files within MongoDB using GridFS. So far, we've mostly talked about how, when using documents, we need to think differently about storing and structuring our data. Going deeper, there are certain types of data that are best stored in special types of collections. By default, a collection can store basically any type of document, but MongoDB supports some special types of collections that are designed to handle certain use cases. The 2 we'll talk about here are capped collections and time series collections. Capped collections cap the amount of data, or documents, that can be stored in them, and automatically removes documents once that cap or limit is reached. It also ensures that all the documents are inserted in the order they were created. This is especially great for cases where you have something like log data, where the order matters, but the usefulness of that data lessens over time. Now typically, we just allow MongoDB to automatically create a collection for us. But in this case, we want it to be capped from the start. So to do this, we'll run a command like this, db.create collection. And we'll give that collection a name. So let's just call this error log. And then we're going to give it some attributes, like capped being true. And the size. So this would be the max size that this collection could be before it starts deleting documents out of it. Along with the size, we could do a max number of documents. And right here, we could add that by saying max and whatever that max is, in this case, 10,000 documents. Out of the box, a capped collection requires a max size, not necessarily a max number of documents. However, when the max size is reached, it will automatically start deleting documents. We'll talk about that process in a moment. You could choose a specific amount of disk space you want to use by the size, or you could pick the max number of documents. Either way, MongoDB will take care of this for you. So, how does this automatic deletion work? MongoDB uses a principle called first in, first out, where the oldest data, the first in, is next in line or first to be deleted, i.e. kicked out. So, you never have to worry about running out of disk space due to too many documents, or just keeping around a lot of old data you don't need anymore. MongoDB can do this since the insertion order is guaranteed, as we talked about earlier. You can also convert an existing collection to a capped one, like so. There are a few limitations with capped collections. By default, there is no index, since it doesn't need it, as the insertion order is guaranteed. That means if you need to update your documents, you need to create an index for performance reasons. Also, you can't shard a capped collection. Another type of collection is time series. This is a new type in MongoDB 5.0. Time series collections use some of the same ideas about insertion order, but focus on one or more unchanging parameters. For example, what if instead of just a log, you wanted to store the state of something at a given time and keep measuring and tracking that? An example might be stock data. You might want to track how the stock is doing every 30 seconds during the whole trading day. You could do this in time series collection by making the stock symbol the thing that doesn't change, and some other metadata the things that you track every 30 seconds. You could track, for example, the stock price, volume, high, low, and open price, or even some data about some other stock symbol at that exact 30-second interval. You could use this to build a very rich data set, to do all sorts of queries later on and build out charts or do an analysis. And because we use a time series collection, our data is already optimized for those queries later. Another example might be some kind of sensor data, maybe a really smart smoker pellet grill. We could pipe out the input of the temperature sensor in the grill, the outside temperature, temperature of the meat, and the pellet level every minute. We would then be able to analyze that data in real time, essentially, and see trends like the temperature outside getting colder, so you may need more pellets combined with the current pellet level to send a push notification to a phone to let a user know they need to refill the pellets sooner than they thought. Even better, there are options to automatically delete these documents via a time to live option, so you can cap them like a capped collection. There are lots more options with time series collections, so make sure to check out the docs if this seems interesting to you. Next, we'll have a challenge. All right, it's challenge time. If you're coming from the relational database world, you'll be familiar with joins and the use of multiple tables to construct a result. But we aren't using a relational database, we're using a document database. Now, imagine this scenario. The recipe site is going great. So great, in fact, we're going to publish a book on Kickstarter with our best recipes in it. And the campaign was a great success. But now it's time to ship the rewards. We have a couple of sources of data, mostly given to us in spreadsheets and CSV dumps. We have a list of backers that has a user ID, first name, last name, email, and a backing level. We have a separate list of shipping addresses with a user ID, street name, city, zip, state, etc. And then lastly, we have a completely separate list that has user ID and an item name of their backer reward. And the user may have one or more of these items. So how can we take these different bits of data and instead of, say, putting them in different tables and joining them together, store them in a single document? That is a document for each backer. I put some example files in the lessons/4.4 folder if you're having trouble visualizing the source data. But just remember what we talked about earlier with one-to-one relationships and one-to-many relationships. Next, I'll show you one way we could handle this challenge. So, how did you do? This challenge might have been a little bit harder, but hopefully the solution you came up with was actually pretty simple and elegant. Here's one way we could have solved this. Using our three different data sources, first we'll create a document that has the user ID, the first name, last name, email, and backing level here on line 6. Then we're going to add a couple different combinations of objects and arrays. To get the shipping address, we're going to have an object that has all the shipping address information inside it. And for rewards, since there could be more than one, we're going to have an array. So in this case, the person got a book and a beach towel. Why we gave them beach towels, I have no idea. Take a look at the shipping address real quick. Since we're only going to ship to them once, there's no real reason to store this in a separate table like an address collection. Because we're only going to ship to them once, and once we ship, that address is never going to change again. Similar with rewards, we don't need to link over to another collection or table that says, ID1 and ID2 for book and beach towel. We can just put them right here in this array. So now we can take our three different data sources and put them in one nice, succinct document. In the next section, we're going to talk about how you can code with MongoDB. So far, we've been working with MongoDB directly, and that's all well and good. But what about actually making applications with it? Luckily, there are drivers and libraries for a ton of programming languages and frameworks to allow us to do just that. Here, we'll be starting with Python, but if you're more comfortable with JavaScript or PHP, feel free to skip to one of those videos instead. Each one will cover the same sort of examples. We won't be diving deep or even talking about best practices, but there will be code files and some useful resources provided in the description and the course repo. So, let's get started. The first thing we'll want to do is install PyMongo, which is the official Python driver maintained by MongoDB. Here, we'll use pip, but there are other examples provided in the docs. For our purposes, we're using PyMongo 3.10.1. So let's go ahead and install it. Now I have already installed, so you'll see different output on your screen depending on your setup, but if everything went well, you should be able to connect to our Cooker database, like so. First, we can open a Python shell, and then we'll import PyMongo. We'll set up a client connecting to our local host at the default port, and we'll set our DB variable here to Cooker. Now, we can run db.name, and we should get back Cooker. It means everything's working so far. Now, if we want to run something kind of like we would in a Mongo shell, we could run db.recipes.find1, and you'll see we'll get back the JSON of one of our recipes. If we run, however, just a simple find, we'll get back a cursor, which we'd need to iterate on. To make this a little more clear, I've included a couple test Python programs so we can illustrate various concepts. Let's go ahead and try them. You'll find these in the lessons/5.1 folder in the repo for this course. Here we can find a couple of different Python programs. Let's go ahead and try this first one here. So, it says setting up a Mongo client, connecting to our database. We connected successfully, and we were able to figure out the name of our database is Cooker. Let's start looking at the code for some of these programs. In the case of the program we were just running, you could see we import PyMongo, and then we start our client, our database, and we output the database. Similarly, using the find1 command we did before, we could simply run find1, assign it to a recipe variable. In this case, we're using the prettyprint version, or prettyprint command in Python, And we could run something like this. And it will output a formatted version of one of our recipes. We can also run find, and remember before it returns back a cursor. So we'll need to do a for loop on the find. In this case, we can print out the title of the recipe. So let's go ahead and try that one. Now you'll see a number of titles and recipes in our test database. We can also sort these. So in this case, we have a for loop, and we added onto the find a sort by title. And in this case, we're using pymongo.ascending instead of a 1 or a -1. And then we can use limit just like we would in a normal MongoDB shell. Let's try the last example program here. This one's giving us a prompt and asking us, what would we like to cook? Well, since our theme has been tacos, let's go ahead and ask for a taco. Now it's told us it's searching for taco, and it found the following recipes: chicken soft tacos and tacos. And we have a description here as well as a sentence that's telling us it'll take about 29 minutes and be about 205 calories per serving. So, how did we accomplish this in Python? In this case, we're going to do a standard input to ask the user for a search variable. We're going to output that back again, as well as clear the screen for them. And we're going to say we found the following recipes. In this case, we're assigning our query to a variable, and we're still using it in JSON here, and we're telling it to take the title, and in this case we're using a regex search, if you remember that from earlier in the course, and we're saying case insensitive. That way we matched both kinds of tacos. You could also use a normal find query and try to do exact matches or any kind of variation on that you'd like. Then we pass that query into our find and output, or construct the output rather. In this case, we're going to take the total time by combining a prep time field and the cook time fields. So we can say here that it's about a total of whatever minutes. And you can see various other formatting and uses of fields from our output, and we'll print it right there. And again, it'll end up looking something like this. So if I don't search for anything, it will bring back all of the recipes. If I say I just want meat, then it just came back with meatloaf. Take some time to look through the example files to better understand them, and feel free to tweak them with some of your own changes. If Python's your thing, why not see what you can make with PyMongo and MongoDB? Have fun! Unless you've already watched the Python or PHP videos, so far we've been working with MongoDB directly, which is great, but what about making actual applications? Node.js is just one of many frameworks and libraries that have official drivers for MongoDB. Again, if you're more comfortable with Python or PHP, feel free to skip to one of those videos instead. Each one will cover the same sort of examples. We won't be diving deep or even talking best practices, but there will be code files and some useful resources provided in the description and course repo. The first thing we'll want to do is install the official Node.js driver maintained by MongoDB. You can see the links, lesson, readme. Here, we'll be using npm and the MongoDB package at 3.5.9. You can set the version when installing if you run into issues. Here, I use --global, but if you are doing this inside your own npm package or project, you can probably just run --save, like it says here in the docs. Now, I've already installed this, so when I run it, the output may be different than yours. I've included a number of example Node.js programs here to illustrate various concepts. So let's go ahead and give them a try. Again, you can find these in the lessons/files 5.2 directory in the course repo. Let's check out this first one. Let us know that it's setting up a Mongo client, it's connecting to the database, and it connected successfully. It also let us know our database name is Cooker. So, how did we do that? Well, in Node.js, we can set up a MongoDB client like so, and then in this case I'm requiring a cert, but that's not necessary. We set a URI, which in our case is a local host and the default port, as well as the database we're wanting to work with. When we actually run the Mongo client and connect to the database, we're going to ask it to tell us the name of the database. We do that by doing database.name on the end of this database connection here. This is similar to in the MongoDB Shell using the getDatabase command. And then we go ahead and close our connection. Okay, that's cool. How do we do something more interesting? To do that, let's check out one of these other examples. So in this case, we're actually running the find1 command, and it's bringing us back one of our recipes in JSON. And we can see it pretty nicely here in Node.js. Now, that's fine, but what if we need to bring back multiple documents? Well, in that case, we'd get a cursor, and we need to iterate over it. How do we do that? Well, in this example here with find, we could see it brings back a number of examples that we have in our database. So let's take a look at these two scripts and how exactly they're working. In the case of the find one, we have pretty much the exact same kind of connection here. I've just cleaned it up to be a little simpler. But we are running it in an async function. And we're doing an await for each kind of major operation we're doing. But as you can see, we still have our database. In this case, I'm going to set collection and set collection to recipes. And then I'm going to run the find1 command. And I can simply output the result of that to the console log since it's already in JSON for us. It gets a little more complicated when we're using find and a cursor. Here, we have pretty much the same setup again, and we run find with nothing passed to it, so we should get back all documents. Then, we're going to iterate over that cursor. So we're going to do an await and keep going as long as there is a next item in the cursor. While we go through this loop, we'll assign a recipe variable to whatever the next record in that cursor is. And then we'll simply write out the title, as you saw earlier. Now, we can also chain on commands. So in this example, we have the find again, but we're going to run sort ascending, which is 1 if you remember. We're going to limit by 3. Then we're going to do the same thing again. In this example, we're going to have more of an interactive program. So it's going to say, what would you like to cook? Well, since our theme has been tacos, let's go ahead and say tacos. This will bring back and say, searching for taco, and we found the following recipes: chicken soft tacos and tacos. And then it gave us the description of the recipe, as well as this combined sentence. It says this recipe will take about 29 minutes and be about 205 calories per serving. So, how did we accomplish this? Well, here, to get the user to input, we'll use readLine and use standard in, standard out. We'll ask the question, what would you like to cook? And we'll capture the response in a search variable. We'll then send that search variable to this recipe search function. Now this looks somewhat like what we were doing before. We have a Mongo client, Mongo connection, but in this case, we're going to do things a little bit differently. We're still going to assign our collection of recipes, but we're going to make our query here on the title, and we're going to make it a regex search, if you remember that from earlier in the course. And we're also going to make it a case-insensitive one. So if I search for a capital T taco or lowercase t taco, each one will match. And since we're doing an open search like this, it matched both chicken tacos and just regular tacos. We're going to send that query variable here into the find and sort by title ascending. And then we're going to console log out that we're searching for whatever you asked to search for, and we found the following recipes. Again, we'll need to iterate over the cursor, and in this case, we're using a display recipe function. And here, we're just simply using some console table and console log outputs to output the title, like this, as well as a recipe description. And the total time the recipe takes here is calculated by adding the prep time to the cook time, setting that to a variable, which we can use down here. Now, as you can see, there's multiple ways to address the fields in the recipe document. You can do it with array syntax here or dot syntax here. Both of them are perfectly valid, just like they would be in JavaScript. Take some time to look through the example files to better understand them, and feel free to tweak them with some of your own changes. If JavaScript is your thing, why not see what you can make with Node.js and MongoDB? Have fun! If you skipped right to this video to see how to use MongoDB with PHP, you're in the right place. Again, if you're more comfortable with Python or JavaScript, feel free to skip to one of those videos instead. We've covered the same sort of thing in those examples. In this course so far, we've been working in MongoDB directly, which is great, but what about making actual web applications? PHP is one of just many languages that have official drivers for MongoDB, and there are plugins for many major PHP frameworks, like Laravel. Here, we won't be diving too deep or even talking best practices, but there will be code files and some useful resources provided in the description and the course repo. The first thing we'll need to do is install the official PHP driver, i.e. extension, maintained by MongoDB. See the links in the lesson README. Here, we'll use the extension at version 1.7.4, so if you have any problems, go ahead and set the version there. In our case, we used this installation method. You can see others in the documentation here, but the important thing is to make sure that your extension is loaded in your PHP ini file once all that has completed. Again, if you need more help, you can find a link to this doc and others in the README. Now, I've included a number of example PHP scripts to illustrate various concepts. You can find them in the lessons/5.3 directory. As you can see here, there's a couple of different files, as well as some composer information. I've set up a basic composer install here you can run, but if you need to run it inside your own project, you can run a command similar to this. Again, this is all documented in the official documentation. So let's take a look at some of these examples. To do so, I'm going to use the PHP built-in web server, which you can run with a command, capital S command like this. But you can run whatever web server setup you have. Here are some of our example files. In this first test, you could see it's setting up a Mongo client, connecting to the database, connected successfully, and the database name is Cooker. So, how did we do this in PHP? Well, to start off, we include the autoload for the vendor folder, which will include our MongoDB library. I'm just including a header and a footer here for styling. But we simply set up a new MongoDB client with our localhost and default port, as well as our database name as part of the URL. We assign that to a client variable, and then we tell that client variable we want to, again, connect to Cooker. That will let us know we can successfully connected, and then we can run the get database name on that database connection. This is very similar to in the MongoDB Shell running the get database command. We output that, and there we go. Well, let's look at some more complicated examples. Here, we're running the find1 command. And as you can see, we're able to get a JSON object back that's showing us one of our recipes and showing entire things like the ingredients, our likes, etc. That's pretty nice. This example will run the find command, which will get back multiple recipes from our database. And just show the title in this case. Because when we get back something from find, it's in a cursor. So we can't just output some JSON. We actually have to iterate over that cursor. Again, we can also run sort and limit on these. In this case, we get 3 recipes ordered alphabetically. So how do we accomplish that? Well, for the find1 example, we have the same basic setup and connection. In this case, I'm going to assign a collection so I can run find1 command on the collection. You'll see it's using our cooker database and our recipes collection. And then I'll just simply take the result of that recipe, run it through JSON encode, and it simply outputs JSON. Find is a little more complicated, but still pretty straightforward. Again, we'll get our recipes collection, and we'll run find on it. And then we'll run a for each to iterate over the cursor. And we'll output the title. To do the sorting and limiting, I'm going to add an extra options to the query. And I'm going to set sort on title to be 1 or ascending, and I'm going to set limit to 3. I'm going to make that the second parameter of find, and then I'm going to send an empty array as the first parameter. It's very similar to sending an empty document on the command line version of MongoDB. And then we simply output our title. Well, let's look at a slightly more complicated and interactive example. In this 5th one, we get a form where we're asked, what would you like to cook? Well, since the theme of our course has been tacos, let's just go ahead and search for taco. You'll see it brings back 2 different results: chicken soft tacos and tacos, with a description of the recipe, as well as a sentence that's letting us know this recipe will take about 29 minutes and be about 205 calories per serving. So, how did we accomplish this? Here, there will be some more HTML for formatting purposes, but basically we just set up a form with an input, and then we set a collection to recipes once again. But in this case, we're going to break out our query into its own variable. And it's going to be an array syntax, and we're going to do title, and we're going to use a regex search, if you remember that from early in the course. That way we can match chicken tacos and tacos by just typing in taco. And we're going to put in options on that of I, or insensitive or case insensitive. So we don't have to worry about if someone typed a capital T tacos or a lowercase t tacos. Once we have our query set, we'll send that as the first parameter to find this time, and have slightly different options where we're not limiting, but we are still ordering ascending for the title. And then we'll iterate over that and do a very similar thing. But in this case, we'll have a total time variable. Well, we'll take the recipe prep time, the recipe cook time, and add them together so we can display them in this sentence down here that is telling us about the total time and the number of calories. Again, we can just reference in array syntax the field we want on the recipe document that we assigned up here as we iterated through the cursor. So, take some time to look through these code examples to understand them a bit better. Feel free to modify them with your own changes and try something out. If PHP is your thing, why not see what you can build with PHP and MongoDB? So far, we've been working with MongoDB directly, and that's all well and good. But what about making applications with it? Luckily, there are drivers from many different programming languages and frameworks to do just that. Here, we'll be using Go. So if you're more comfortable with Python or PHP or JavaScript, i.e. Node.js, then make sure to watch those videos instead. We won't be diving deep or even talking about best practices, but there will be code files for you to check out. The first thing you'll need to do is get the Go drivers using this command. You can also check out the docs on the MongoDB website. There's lots of great information there. Once that's installed, you'll be good to go. I've included a couple example files in Go here in the Lessons 5.3 folder. So let's try them out and see what they do. So let's try this first one here. You'll see it has connected to the database successfully and listed the different databases we have on our server. So how did we do that? So I'm going to go ahead and open these files in VS Code so we can go through and look at them. First one you'll see here, we need to import a couple things, like the drivers for Mongo. And then we're going to set up our client here on line 18, and that's going to connect to our local host on the default port. And then we're going to let it know that we're connecting to the database, and that's what we're doing here. And each of these has a fallback because there's an error that defaults back on each of these, along with the client or the context or whatever you're doing. And then we'll connect the database and we'll run this list database names on our MongoDB client. And that gets us all our database names, and then we're just printing that out. So pretty simple and straightforward. Next, we can try the second one here. And this one is going to run the find one command, and it's going to bring us back one document, which we can see here in JSON. So how do we do that? We're going to add to what we already had here, where we're just connecting, is we're going to specifically connect to a particular collection. And we're going to get the results here, and I'm just typing this as bson. And then we're going to run the find one command here on line 36. And we're going to send it an empty document. So it's the same as doing find one with an empty document. And then down here, we're going to get our output, and we output it with some JSON formatting for us. Next, we could go a step further and use the find command to find each of our recipes and just print out its title here. So the way we did that is a little different than what we were doing. So in this case, on line 31 here, I'm going to type what I want a recipe to look like when it comes back. So I'm just getting the title, and I'm telling it title here, and over here is what isn't actually in our database in bson. Again, we're going to connect to our collection, cooker collection here, and we're going to run the find command here on line 37. And again, we're going to give it an empty document. And this time we're going to get back cursor, because we're getting back multiple documents. So you could either iterate over that cursor, or in this case, I'm just printing them all out like an array. Lastly, we can try our fourth example. In here, we're going to find a specific recipe by looking for it and also sorting and limiting. So how do we do that? So we're going to connect same way. I'm now going to expand my type here to include the title, the cook time, and the description. And you'll see this is title, cook time, and description, what's actually in the database. And then I'm going to add a search document to this, which is going to search for recipes with the title of apple pie. And then I'm going to add some query options to it as well. So I'm going to add a set sort and make it sort by the title, ascending, and I'm going to set a limit to 3. Now, of course, we have very few documents in our database, and only one of them happens to be apple pie. So either way, this is always going to bring back one document. But if I, for example, took off this filter, I would get back 3 documents ordered by the title. And then we're going to send on line 48 here to our find our filter up here and our options for our query. And then we're just going to print out our recipes that have been typed with this recipe type. So now that you've gotten a taste of MongoDB with Go, why don't you go and make something great with it? You can not only store documents in MongoDB, you can store entire files. This opens up a lot of possibilities, not only for better organization, but also application features. To do this, MongoDB uses what's called GridFS, a technology that will break up the contents of the file into chunks, each stored in its own document, and also store the information about the file itself in a sort of parent document. When you need the file back, MongoDB will simply stream the chunks back to you. A great way to get started with GridFS is to use the Mongo files binary that's included with database tools. Refer to that video if you haven't installed them already. Using the Mongo files binary is simple. I can simply ask Mongo files to list the files that are currently stored in GridFS. For this database, it's called files. So we'll list our DB called files. And I'm going to add this quiet part here, just so we have a little less output. And you'll see we have 6 different files uploaded into our database. These all happen to be images. To better illustrate this, I'll use MongoDB Compass that we used briefly earlier in this course. As you can see, we have a files database and 2 different collections inside it. If we look at this fs.files, you'll see each of those files we saw earlier, this Colorado Springs Christmas, soccer, DC, empanadas, Pike Place, and Pikes Peak. We have the length of the file or the size, and the file name, and some other information here. You could also add additional metadata or things that you want to add to this, like titles or descriptions or credit, etc. You'll also notice that the ID here is just like a normal document. If we look in this fs chunks collection, we'll see an ID and a files underscore ID. This file underscore ID refers to the ID in the fs files collection. In this case, we just have 6 chunks because these files aren't particularly large. The maximum document size is 16 megabytes, and these are much smaller, so we only have 6 chunks. Now, if we had bigger files, you'd see a lot more chunks for certain files. Now, how do we get the files back out? Most of the time, you'll use the Mongo client library like in Python or PHP or Node. Here, we'll use the Mongo files command itself. So, I can do Mongo files, and in this case, I'm going to get something out of it, and I'm going to get the Pike Place.jpg out of the DB files. Now, when I list the contents of this directory, I have a Pike Place JPEG inside it. So I can go ahead and open that. And you'll see it's a picture of Pike Place Market in Seattle. Now, let's store some new files in GridFS. First, we'll upload an image we can use for our recipes. Inside the 5.5 lessons folder, I've included an images directory with a couple example images for you, including the ones I've already uploaded into the database. We can use the Mongo files command again, but this time we're going to put something in there, and we're going to put this apple pie.jpg, and again we're going to specify our database to be files, and that will say it's connected and added the file into our database. Now I can run Mongo files list, and again specify files and the quiet, and you'll see apple pie has been added. And again, if we go to Mongo Compass and refresh this, this now has 7 documents, including our new apple pie document and file we just uploaded. Now let's try another type of file, a bigger file. For a bigger file, I'm going to go to the Internet Archive and get a copy of the book Ozma of Oz. It's one of the books in the 100-Year-Old Oz series. And we see here we can download a PDF. So I'm going to copy the URL to this, and then I'm going to download it into my folder. Once that's done downloading, I'll have a copy of the PDF in my folder, and I'm going to add that to my Mongo files. So again, Mongo files and put, and in this case, the Ozma of Oz PDF, and my DB files, and it's added that correctly. And if I go into Compass here, we'll see we now have 8 documents. But if we go into the chunks, we now have 58 chunks because it was a much bigger file and had to be spread out amongst a lot more documents. Now, if we want to delete that back out, we can use Mongo files and delete the Ozma of Oz DB files, and we've successfully deleted that file out of GridFS. Lastly, there's an example of using GridFS with Python in this directory. So it's called example.python. We'll see it outputted the contents of something. And if we go into Compass, we'll see there's now a new file called text.txt. And if I go check that out, this Python script, essentially what we're going to do is connect to the MongoDB instance and attach to the GridFS files. And then I'm actually creating a file with the contents of test123 and giving it a file name of test.txt. And then I'm taking out of the database, getting the file, and printing out its contents. You could also make a PHP or Node.js or Go script to upload or pull images out of MongoDB to organize user-uploaded recipes for images, for example. Or you could use this as an organizational layer on top of a CDN like S3, so you could keep your source images in GridFS, but actually serve them off S3. Next, we'll cover topics around server administration. You can configure just about anything you need to via the command line options when you start up MongoDB, like the --db path for the location of the data files, but MongoDB's config file let us do this more easily and safely. The location of the file differs based on your OS and can also be manually configured. See the lesson description for more on that. The files themselves are written in YAML. Let's take a look at an example config file and see some things it can do. So in the 6.1, which is this lesson's directory, there's a MongoDB conf and a sample conf. Let's go ahead and look at the MongoDB conf. We'll see a couple things right off the bat here. For logging, we are using a log file, and we're telling it a location it can be, and we're appending by default. Now, this can be important as log files can fill up sometimes, so you may want to put those in a particular location, like on another disk in your database in production. Now let's move on to storage. This is where we could set the DB path for the files as mentioned before without having to do it when we start up with that -db. With a net, we have a bind IP and a port, and that could be important if you need to change things for security reasons or for replication. There are a bunch more options, so let's see a couple more of those. In the sample conf, we're going to demonstrate a couple more powerful options of MongoDB. In this case, I've put the log files somewhere else in my system. I've also put the DB path somewhere else, so I could specify it to a specific disk. I also set directory per DB true. I like to do this personally because you can separate out your databases onto different physical disks, for example. And you can do that easily since each database will have its own directory and you can mount different directories to different disks. Other things that might be important are the max incoming connections. This happens to be the default, but you may need to change that for your usage. Another interesting thing under process management here is fork true. By default, MongoDB won't fork itself, so it won't be a background process. Fork will make it a background process by default, and this is most likely how you'll actually want to run things in production. This is how most databases run. Security is another important aspect. In this case, I have authorization enabled, which will require role-based authentication. JavaScript enabled is another thing you may or may not want to enable. There could be some security issues if you allow JavaScript to run, but if you don't, you can't do things like import a JSON file of a collection. Replication is another important bit. Here, I'm setting the default replica set name, which needs to be the same for all members of the replica set. To use the config file, you simply pass a --config when you start up MongoDB. For example, you would do it something like mongod --config and the location of wherever your file is. So actually here, we could just run it like that, mongod conf. For Windows users, it may end up looking like that, so that's a 3-letter file extension. Take a look at the lesson notes and README for links to more config options and how those line up with command line options. In the next lesson, we're going to talk about replication. Throughout this course, we've been running a standalone database, which is fine to get things started, but it's not recommended for production. What if something goes wrong? What if your server crashes or becomes unavailable? While you might be able to fix things quickly, you'll still have some sort of downtime, and downtime isn't good. Or worse, you might have a disk problem that corrupts your data, and that'd be really bad. Replica sets are MongoDB's way of helping you avoid these problems by running multiple identical copies of your database at once. It does this by having a primary node and multiple secondary nodes. The primary copies all the data to the secondaries, and if the primary ever goes away, one of the secondaries automatically takes its place. This also helps for scaling your database. To show this, we're going to want a clean slate. So I'm actually going to set this up inside a Docker container running Linux. But none of that is actually necessary for you to do, and you can follow along in your local machine. Now I'm going to set up 3 members of this replica set on my one host here. In production, you'd want to do this on 3 separate hosts, i.e. servers. So I'm going to start here by opening 4 tabs and connecting to my Docker container in each. I've already installed MongoDB in the container, but I haven't set it up yet. So I already have 1 tab here. Let's open up 3 more. And I'm just going to connect to the containers. The first thing I'm going to do is make a place for the data files to live. So I'm in my root here. I'm going to go ahead and create a folder called store with another folder called data inside it. And then let's go ahead inside that folder. And I'm going to make 3 separate directories, one for each of my replica set members. So we'll just call this rs1, and we'll make another one rs2, make another one rs3. So now we have 3 directories in there. Next, we're about to run a version of MongoDB in each of our 3 terminals, and we're going to run a special command. So here, we're going to run mongod and give it this repl set command, and we need to give it a name. Now this needs to be the same everywhere we're working, so make sure you get that name right. And then a db path, which we just created, so store data, and this one will be rs1. And we'll give it a port, because each of these is going to need to run on a different port. So we'll let this run on the default port. And we'll add 2 extra options at the end here. And this is, you can configure these for your actual production use, but this will be best for our example. I'll give it small files and an opt log size of 200. So let's go ahead and copy that so we can use it again in the next terminal. And we'll see this starting to run, and it's waiting for connections on port 27017. So let's do that again, but this time we'll run on port 18 here, and we'll give it rs2 for the folder, and everything else will remain the same. Let that start running. Now it's listening for connections on the other port. Lastly, we'll create a third. Change the port again, 19. Those ports could be whatever you want. I'm just doing that for ease of use. Now, waiting for connections on port 19. So, if I run htop, for example, I will see multiple versions of MongoDB running here. 3 in fact. And that's for each of our replica set members. So next thing we'll need to do is actually tell these replica set members that the other ones exist. They don't actually know it yet. We don't actually have a replica set yet. To do that, I'm going to go ahead and log into that first one that was running on port 27017. And I'll just clear that out. And once we connect here, we need to give it a configuration. So we'll just make a variable name here called config, and we'll give it a underscore ID, and we're going to make that match our cooking set that we set earlier. And then we need to give it some members. So members, and we'll give it an array here of members. And that will consist of an object representing each one of these 3 servers that are running. So they need a ID themselves, so we'll just say 0, and the host, so that's just localhost and whatever port they're running on. In production, again, this would be, a different machine. We'll just go ahead and copy this, and we give it our first one, and then we'll give it our second one, port 18, ID 1, and then a third one with 19 and ID 2. And then we'll close out the array and close out our object. And it will spit it out nicely formatted for us. And we're just going to send that to the command rs.initiate. And we're going to give it our config. So you can see it ran, and it tells us right now we're on the secondary. So this could change at any time. If we're doing this from scratch, we could run it on any of these members. But if we already had data, we'd want to run it on that member first. So right now it's saying we're on the secondary, as you can see here. This prompt changed. So I can run this rs.status command, and this will give us a whole bunch of information about our replica set. But the important part is this members portion. And you can see in the members portion, 17 says it's primary, 18 secondary, and 19 secondary. And you'll see, in fact, this automatically changed to primary because we're on the one with port 17 and it has been elected the primary. There's some other interesting commands you can run, like db.isMaster, and that will give us kind of a smaller, more succinct summary of this. It lets us know our hosts, our set name, as well as some various information about what's going on in a replica set. Now, one of the most important things, of course, is actually replicating data. So the first thing I'm going to do is actually log out of this primary, and we'll just exit. And I'm going to log into one of those ones that said it was a secondary. So as you can see here, our prompt has changed to secondary. And if I do show DBs, you'll see it says database list failed, not a master. So if we want to run commands on this, we actually have to set a slave OK to true. But we're not going to do that right now. The whole point is we can't run commands on here. And we also can't write to it. So I'll go ahead and exit the secondary, and we'll log back on to our primary. And I'm going to just create a blank document. So db.testo.insert1, and we're just going to give it an empty document here. So when we run this, it's going to replicate this across our different replica sets. So if I look here, for example, I'll close out the output on the other replica set members. And when I run this, you'll see it got the message to create something in the test database called testo. So did this one, and so did this one. So now each of the replica set members have a copy of that in storage. You'll notice different connections here, etc. Sweet. Now we have 3 identical copies of our database. By the way, while you connect to each MongoDB individually, you can only write to the primary again. Lastly, to connect to the replica set properly, you'll want a slightly different command. You'll want to use a connection string. So instead of here connecting via the port, I'm going to do something like this, which is a whole connection string that lists each of the members, comma separated, of our replica set. And then we're also going to say what our replica set is named. And then when I connect to that, you'll see it's similar, but it automatically connects me to the primary, so I can go ahead and do whatever I need to do. There are a bunch more options for replica sets, so make sure to check the lesson notes for links and more info. Next, we'll talk about a related idea, which is sharding. Going through an entire sharding setup is beyond the scope of this course. However, having a fundamental idea of what sharding is and how it works is important, so later, if you need it, you can have a smooth transition to a sharded server setup. Sharding is the concept of breaking up or partitioning your data across multiple servers. This can be helpful for performance and overall infrastructure. Instead of scaling up as your data grows, i.e. buying bigger and bigger servers, you can scale out or across multiple servers. You can also spread things out better depending on your usage. For example, if you need more disk space but not as much RAM, you can max out your disk and save some money elsewhere. Now, partitioning is possible with some other database systems, but almost all the time it involves a lot of manual intervention and pretty complicated setups. With MongoDB, we can auto-shard our data, which is awesome. Before we continue, it's important to understand why the ability to use sharding is really cool. It is easily one of the most complicated concepts and setups with MongoDB. So for many basic and even moderate MongoDB setups, a replica set is probably all you need. Nonetheless, let's talk about the aspects of a MongoDB cluster, which is how we refer to server setup of a sharded database. As we briefly touched on, sharding takes your data and breaks it up amongst multiple servers. This differs from a replica set, which is a copy of your data on multiple servers. A replica set replicates your data on any server in the set, whereas sharding breaks up the data between the servers. In a replica set, when you connect, your queries are automatically delegated to one of the members in the set. This works great since each member has a copy of all the data. So how does MongoDB handle sharding when the data might be broken up into multiple servers? To do this, we use another process called MongoS, so not MongoD. This process works like a router and contains something like a table of contents, keeping track of what data is where. It does this by using something called a shard key, along with config servers, which we'll talk more about later. So, when you connect and send queries to MongoDB, MongoS will handle looking up where that data is and getting it from the right server, and also merging that data together if it resided on multiple servers. Best part is, it does this all under the covers, so it just acts like a normal querying connection. You don't need to do anything special on the application side. Your client connects to MongoS, and the config servers, here shown with a replica set, keep track of where the data is, and the other replica sets shown here store the data. We already talked earlier about how we should use replica sets for our data, and the same goes for config servers, since they store where your data lives. If you lost that table of contents, you'd have to manually reconstruct it, which would be a nightmare. So, run a replica set for your config servers and back it up often. The good part is it's only a small amount of data. So, how does MongoDB automatically shard this data? The first thing you'll need to do is enable sharding on the database and then tell it a collection you'd like to shard, as well as a shard key. MongoDB will use this key to break up our data. The key needs to be something that can be indexed, because it basically is an index. So imagine this example. We have all our recipes in alpha order by title, all stored together. Apple pie through zucchini brownies. If we chose the recipe title as our shard key, MongoDB would break up our data by title. So something like this. Now our recipe data is broken up into 3 shards, in this case all evenly spread out with 3 recipes in each. Now in reality there'd probably be thousands in each shard, depending on the way you break up your data. But in this case, we have everything A through B and all the recipes, F through M, and then T through Z in the last shard here. As we add more recipes, MongoDB will look at the shard key and add the recipes to the correct shard. If a shard is getting too big, what's called unbalanced, it automatically splits up the shard into 2 or more new shards. You could also use the _ID as your shard key, and essentially your data would be sharded by the document's creation date. You can also use a compound shard key, like a compound index, but you should be sure that it matches the types of queries you're making, or that could be non-optimal. The location of the data, which shard, is stored in the config servers. Again, MongoDB does this all automatically behind the scenes, and in most cases, you don't have to change a thing about your application code. So if you think you'll need sharding in the future, or maybe even if you don't think so right now, take a little time to think about how to construct your documents, and if that can be sharded well. Next, we'll talk about authentication and authorization. Securing your databases is very important, and while you might be able to accomplish some of that by keeping your database behind a firewall or other network-based security measures, you should still strongly consider setting up authentication and authorization with your database. First, let's talk about the difference between the two. Authentication is like logging into an account. For this, MongoDB has usernames and passwords, or keys, you can use. You can think about this as like having a badge to get into an office building. Authorization is a different concept. It means even if you are logged in, you may or may not be authorized to do certain things. For this, MongoDB has different roles and privileges you can assign to users in what's called role-based access control. So with our office example, your badge might be able to get you into the building, but it might not let you in the executive conference room or the server room. By default, authentication, or access control, isn't turned on for MongoDB, and there are no user accounts. So let's go ahead and create an account and turn on access control. First, we'll need to have MongoDB set up without access control, which, as we already talked about, by default, it isn't. Now, we'll log into the shell and use the admin database. So right here I have MongoDB running, and I'm going to log into the shell, and I'm going to use the admin database. And we're going to run a command inside it. Let's go ahead and open that up in VS Code so we can see it nicely. This is the db.createUser command. We're going to create the user taco, and we're going to specify a password. In this case, I'm using MongoDB 4.2. Anything 4.2 and above, we can say this password prompt command, so we don't have to type a password in here in free text. And here, on line 5, we assign some different roles. We're going to assign the role of user admin any database inside the DB admin, as well as granting the general read-write any database permission. Now, we could change these around if need be, because by giving them user admin any database as well as read-write any database, we're basically making them a super user. So for a user that just needs read data, for example, we could just grant them read any database. So we'd take out the write here and just make it read any database. Now they only have read privileges. Additionally, we could restrict it even further by just making it read and assigning a database like we did here in this object. Now they would only be able to read within that specified database and no others, unless you grant them separately. Note, when you make the user roles like this with the read only, they can not only not write, they also can't do things like create indexes or run a backup. So make sure you have those configured properly for each user. Let's go ahead, copy this command, and we'll run it inside our shell. It will ask us for a password. Just going to make it 1, 2, 3, 4, 5. very secure. And it's going to tell us it created the user correctly. Now, what we're going to need to do is shut down and restart the database. So to do that, we will run this admin command here and do shutdown true. And that will shut down our database. And you'll see here, it's exited the process and told us it shut down. Now we'll need to edit the MongoDB config file and add that we're going to enable authorization. So, and exit the shell here since we're not connected anyhow. And I'm going to edit the Mongo conf file, which in my case resides here. And I'm going to scroll down, and you may need to type this out in your file, but I already have it commented out here. And we'll uncomment security and authorization and make that enabled. And we'll go ahead and save that file. And now I'm going to restart MongoDB here. So now it's restarted. And you'll see if I just try to connect to Mongo here, once you have this running, there's basically two ways to authenticate. You could do this while you connect. To do this, we'll need to specify what database we made our authentication database, which if you remember earlier was the admin database. So we can do mongo -- authentication database. So authentication database. Oh, let me fix this. Authentication database. We'll tell it that it is the admin database. And our user was Taco. And -p to let us enter in a password. And we'll do that. And we'll see we're now connected properly. You can also do this after you connect. So in this case, we would use the admin database, and then we can run the db.auth command and give it whatever username, so taco, and we can use that password prompt again command. Close that out, and now it'll tell us to enter our password, and 1 means we successfully logged in. There are lots of different roles and permissions and combinations thereof you can use, so make sure to check out the docs for your use case. You can see links in the course description. Next, we'll talk about another very important thing you should do in production: backing up. Backups. Seriously, back up your databases and also test your restore plans. Of course, like any good database, there are a number of ways to accomplish backups with MongoDB. We will talk about 2 of them: copying data files and using the MongoDump and MongoRestore programs. The first method we'll talk about is one of the easiest, but also one of the most manual, and it has some drawbacks. Right now, I'm in the db path directory from where I started MongoDB with the -- db path and some directory. So in here, you can see all the files from MongoDB. What we're going to need to do is back these up. But before we do that, again, to do things right, we need to stop any writes to the disk so we can copy these files and then immediately turn them back on when we're done. To do that, we'll go ahead and log into MongoDB on the shell, and we'll issue the command db.fsync lock. And this will tell us it's now locked against writes. Things are still getting written in the database, they're just in memory right now. So we need to hurry up and copy the files so that we don't lose anything in memory. So what we're going to want to do is copy all these files somewhere as a backup. For example, if things were in the data/db directory, we could do something like this: copy recursively all the data files into wherever our backup location was. Once those are done copying, we can go back to MongoDB and issue the db.fsync unlock command. And it'll tell us the unlock has been completed. This has an obvious downside. If anything goes wrong in the database during the backup, any non-written data is likely to be lost. However, in many use cases, this is a manageable risk. In fact, you could just shut down MongoDB completely and then copy the files and start it back up. It would have the same effect. Or, if you have a maintenance window, or even better, if you're using a replica set, which you should be, you could take one item out of the replica set to do this backup, and this might actually be the best option. And then you're going to have no downtime at all. In either case, when you need to restore, simply stop MongoDB, copy the backed up files into your MongoDB data files directory, removing any existing ones, and restart MongoDB. The other method is using MongoDump and Mongo Restore. To use MongoDump, we can literally run Mongo dump, and it will just start spitting out files into a dump folder. If I look in this dump folder, you'll see there's a folder for each database, and inside there's the files for the collection. If it's not running default port, you'll need to specify the port. And you can see more options by running mongo dump -- help, because you can actually back up individual databases, individual collections, or even run a query and just do partial documents you want that match a query. To restore, you could simply run the Mongo restore and give it the dump directory. Again, this could be just a single database or a single collection, depending on how you back things up.